Hello everyone, this is Suresh from Azure ADB. Today our topic is how to generate millions of records using Cross Join in PySpark. So if you see my playlist already, so I already created similar topic by using two different methods. So one is first video is on this by using Cross Join, but Cross Join with a different methodology. And scenario 9 is by using random methods, by using random functions. And this is third one by using cross join, but by using different approach compared to scenario 8. So before watching this video, I recommend to watch uh, other videos, so which are in my playlist. This is my Python playlist. So here I recommend to watch video 10 and 11, and similar way in this PySpark playlist, if you come to video 100, from 100 to 100 to 111. Okay, so then now we'll come to our actual topic. So what we are doing is I have one sample data frame here uh, that if I try to read this particular data frame, so what I did is I try to print number of records in dataset as 20 and number of distinct records in this dataset as 50. Okay, df.count, df.distinct.count, and I'm displaying this data frame. So this is our sample data frame and it has 50 rows. So now what I'm trying to do is, so product underscore df. What is this data frame? This one. So from this data frame, I'm trying to pick only first row. So that is limit 1. So it will pick you first row. Then what I'm doing, I'm using spark.range. So I'm generating numbers between 10,000 to 3,10,000. And on top of that, I'm adding one column like value, and I'm using percent module 100. And later I'm converting to integer type. So what we'll get is, if you come to at the end, see this is our initial data frame, initial column, that is by using up to here spark.range 10,000 to 3,10,000, that it will generate in this column. And on top of that, we added value column and we converted to integer type. What it generate is this one. So it will do module by what we given module 100. So it will try to divide by 100. If it is whatever module comes, it will give you. So if 10,000 by 100, it will give you 0. So this will give 1, 2, 3 like this. Okay, so that's about up to here. So next, what I'm doing is df.product. So that means this single row, I'm doing cross join with this one. So that means this whole data frame, this whole data frame, I am doing cross join with single row. Single row means this one, only this first row. After doing cross join, so that means what is happening, one row doing cross join with this 3 million rows. So this one row, 1 into this 10 million rows, or 3 million rows. So after doing cross join, it will generate you 3 million rows here. So after generating 3 million rows, I am trying to drop these many columns. Okay, so after doing cross join, so I'm trying to print df underscore join count and distinct count. So it will giving you 3 million and distinct count also 3 million. And this is the data frame. Okay, so this is the data frame after doing cross join. So now what I'm doing is um, same code for single row, 10th. Here what I'm doing, initially I given range up to 3 million, 10,000 to 3 million. Instead of here, I'm giving 10,000 to 1,10,000. So here I'm generating 1 million rows. So up to here, code is same except this range value and this single row, I'm doing cross join with this 1 million rows, and later I'm dropping this. So if you see here, it giving 1 lakh row, even distinct values also 1 lakh. So next, what I'm doing, since it is generating all unique records, like duplicate records, because single row we are multiplying with 3 million rows or 1 million rows. So that means all the rows has duplicate records. So to randomize this data, what I'm doing is I'm using when and rand function. I'm importing this when and rand function. So I'm trying to alter the values of each and every column. So for that, what I'm doing, df.join means this data frame. I'm updating product underscore ID column where it is coming product underscore ID, product underscore type is there. Product underscore type, flag is there. Product underscore ID, version ID, subversion ID. So I'm adding these 5 columns to this data frame, that is this one. So one is the product ID that has to fill values of ID column, and product version ID. This also has to fill values of ID column. Product subversion ID, that is 0. These 3 columns, it has to fill with zeros, constant value. And these 2 with ID column values. And if you go here, result, if you come here, see this it generated product ID, product version ID. So these 2, it has to fill values of ID column, that is this one. So this same thing it is filling here. And a similar way, product subversion ID, base ID, profile ID, since we given lit 0, it will generate all 0 values for this column. So now we added 5 new columns, and now we'll try to update now existing columns. If you see now product underscore type here, product underscore type, if you see here, you can see all automatic. So that one, I want to randomize the values. How I'm doing? I'm using when and otherwise function. So inside that I'm using random function, and I given less than 0.5. So that means for 50% values, I want to generate with automatic and remaining 50% manual. So that means it has to generate a random value. Rand means it will generate a random value between 0 to 1, between 0 to and 1. So then whatever it generate random value, if it is less than 0.05, then it should print as automatic, otherwise manual. So similar way, this product underscore flag also same. If you see product underscore flag, this one. So we have only yes. So I want to print 50% yes and 50% no. So same syntax I given, rand less than 0.5. Okay, so next I want to update source. source column. So if you see source column now, currently, see it has only one source REST API. Because while doing cross join, no, one row with 1 million rows, it duplicated, all rows duplicated. Means whatever data in this, same will be in these also. So now we are trying to alter this data. So now that single REST API, no, we are changing to different sources. So how we are doing? I'm using when, I'm using rand function. So whatever rand value generates between 0 to 1, if it is less than 0.3, it will print as REST API. That means out of 100, no, so 30% will print as REST API, remaining 30% as MongoDB, next 30% as Salesforce, and now here total 90% covered, and remaining 10% it will print as Cosmos DB. And if you see here, source column, see earlier only REST API was there. See now all is there. Whatever we mentioned, no, 4 sources, so it will print randomly. And now we'll come to category column. So here, if you see initially category, we have only standard. So that I want to update with different categories. So first 30%, it has to print with standard. Next 20% medium. Next 20% average. And next 20% high. Now 3, 5, 7, 9. So total 90% over. So remaining 10%, it has to print with lowest. Okay, and if you see after updating this category, see earlier it is only standard. Now it updated with all these 5 categories. Okay, next we'll go for index column. So index, initially how it is, we have only true. That I want to update with true or false. So for that, I'm giving rand less than 0.5. So that means 50% true, 50% false. And if you see here index, see after updating, see here, both we are getting true and false. And a similar way, after index, we'll go for location. And if you see location here, we have only IND. So that I want to update with different countries. See for first 30% India, next 30% UK, next 30% Russia, remaining 30%, remaining 10% Japan. And if you see here location column, see it updated with different countries. So similar way, after location, I'm coming for last date. So this one, if you see our long type single value, so it is unique all over. So this I want to print random values. So for this, what I'm doing, when rand less than 0.5, I want to print this one. Otherwise, this one. So that means 50% with this value, remaining 50% with this value. And if you see here, you'll find different values, here one, here one. And if you take a distinct on this particular column, you'll find 2 long values. And next come to start underscore customer date. So this also long type, start underscore customer date, no? Start underscore customer date and end date. One more is end date, that is start underscore customer date, this one, and this is end date. So these two I'm trying to change. So these two, how I'm doing, so here also I'm giving different conditions for start underscore cust date. So first 12% with this value, then next 12% with this value. See like this 12%, 12% I given total different values, and remaining percent with this value. So total 1, 2, 3, 4, 5, 6, 7, 8. So initially we have one value. So now I want to update with 8 different values. Okay, so similar way for end date also. So here also I want to update with different values. So like this 12%, 12% like that. So and one more column start underscore customer underscore date. See now this one after updating with this function, you will get it as in long type. Okay, integer type we will get, but we want this data type as long type. So I am converting this one to long type. Similar way, end date and last date. This one, end date and last date. See, this also will get it as integer type. So these two also I am converting to long type. So see, after running this, see, these are all we are getting with the different values. These are all now not earlier. These whole records are unique records, means unique rows. Now it is not like that. Okay, so now iteration 2. See here I selected few columns. Okay, here I selected few columns and I given different ratios here. So similar way, I will go for a different approach here. Same code, but different ratios and different columns. See earlier, these two common as compared to earlier, and subversion ID here I am keeping 0, and product based ID 2, these 3. So earlier I kept as 1, 2, 3. It seems yeah, all zeros. So here instead of all zeros, I am keeping 1, 0, 2, and 3. And next, I am going for product type. I am selecting product type column. I think this column we are not covered in this. I think product type. So product type, okay. Here we given only 2 types, either automatic or manual. So here what I want to do, I want to do more. So automatic, manual, and AI. Okay, so these 3 types I want to update. So first 40% automatic, next 30% manual, remaining 30% AI. Okay, so like this I altered the ratios here for source, category, index, location, last date, start underscore customer ID. See earlier I used more ratios, no? Like if you see 0.12 I used, I think earlier. See here 0.12 I used. Now that ratio I changed 0.12, 0.15, and this number of unique values also I changed, reduced. And this is same. Since it generates integer type, I'm converting to long type. See, since I'm limiting here, limiting to 600 rows, generating only 600 rows. Otherwise, if you simply give only display of this product underscore df, you will get here 1 million rows. And iteration 3, so you can try in different way, like altering these ratios. I think up to here I kept same as first iteration, and remaining things I'm little bit changed. Okay, so code is same. So only I altered these values, percentages and values I altered. So that is iteration 3. And next, here what I'm doing, I'm trying little bit different. Like so minimum value I mentioned here and maximum value. So here I am defining manual way, fixed values underscore customer. So these many integer values I'm defining here. So this is for what we have fixed underscore value, one column is there. So that one we are updating here. See, I think fixed underscore value we are not covered in this. So we are not covered in this. So I am doing separately. Okay, so this column, how I want to update is, I want to generate random values. So see on this particular topic, no, I already made one video uh, on this arrays. You can check in my PySpark playlist. Okay, so on high level, what it does is X in fixed value cast. This one, no, it will iterate one by one. Since this is list, no, it will convert into data frame array. And after converting, because I want to fill this column with random values, no, so I given this many values. So for each and every row, it has to pick randomly one of the value from this, and it has to update that particular column. So for that, for randomly picking, so I given here rand. Rand means it will generate random values between 0 to 1, and I'm multiplying with length of this one. So this length, and I am converting to integer. Whenever you give star and length of this, it will give you some value, no, maybe 10 or 12 it will give you. So that means that random value will generate between 0 to 12. If you don't give this, and if you mention only rand, that random value, it will generate between 0 and 1. Since we given star length and this, it will generate between 0 to this value. You assume that this is 12, then it will generate between 0 to 12. And later we are converting to integer type. So now what we are doing is, on this data frame, we are adding column cust underscore value. So here what we are doing is, we are using rand. We given a when and otherwise. So when random is less than 0.4, then we had to use these fixed values. Otherwise, it has to use this random value. So that means if you see in customer underscore value, if our random, whatever here it generates no random value between 0 to 1, if it is less than 0.4, then it has to take value from this particular column. That means 40% fixed values. If it is greater than 0.4, then it will come here, and it will take this one. Rand means 0 to 1, random value between 0 to 1. But since we given multiply maximum value minus minimum value, so that we defined here. So maximum value minus minimum value. So whatever value comes now, and on top of that, we are adding with minimum value. So within this range, it will generate random values. Okay, so finally, what we're doing is existing fixed underscore value column we are dropping, and we are keeping our new column. New column generated with these values. Okay, one is fixed underscore value, second one is cust underscore value. And if you see fixed underscore value here, fixed underscore value. It's not available. One more column is, sorry, it will update finally cust underscore value. So, okay, cust underscore value, that is here somewhere, this one. So in this, 40% values will take from fixed underscore value. Okay, so remaining 60% will update by using this logic. Okay, so here we are updating this column, cust underscore value column. And next, similar way, I'm defining minimum value and maximum value, but this time it is for product underscore volume column. So syntax, everything is same, only change in these values. Okay, so here what I did is from product underscore volume column, I manually collected distinct values and I defined here. So after doing this, what it does is product underscore volume column will get update. Product underscore volume, this one. Okay, so this column will get update. So similar way, this is for product volume underscore start. So here also this code is same. Only difference is these values. If you see our initial data frame, product underscore volume underscore start column, we have these values. Okay, so I defined these values. So now while updating this column, no, and if you take distinct of this column, you will find only these values. So these values randomly it will update here. Product volume start. Product volume start, this one. Okay, and similar way, product volume end. So here also code is same. Only minimum value and maximum value is changing, and these values are changing. Okay, so and product volume underscore end, that is this one. Okay, and next, now this is our final output. Okay, so this output, what I'm doing is I am writing to Delta Lake and mode I given append and I given table name as 10 million records. And after that, I'm calling here through SQL this 10 million records, and you can see here. And here, what we want to observe is everywhere I mentioned like iteration 1, iteration 2, like this, correct? No? So why I written like this is now code is understood. Now we'll see what is these iterations. See, in first iteration, that means you assume that I need to update total 10 million rows. Okay, so first I will run this notebook. What I will run this notebooks is wherever I written iteration 1, no, only those cells I will update. Okay, so since I mentioned here iteration 1, 2, 3, that means this cell I'm updating 3 times. That means whenever I run first time, it will give you 3 million records. Whenever do second iteration, it will give you 3 more million records, and third time it will give you 3 more million records. Okay, so it is like that. So whenever doing first iteration, you had to run these 2 cells and you had to run this cell. So that it generates here 3 million records. Okay. Next, since I mentioned iteration 4, now I don't want to run this one. So when it comes to iteration 4, I have to run this one. Okay. So next it comes to here. Since I mentioned iteration 1 and 4, I had to run this one. Okay, for iteration 1. So if you see here a difference, iteration 1, see in iteration 1 here, it generating cross join. That means it generating all duplicate records. Okay, so next in first iteration, what I'm doing, I am updating these many columns. For these many columns, I am randomly generating values. Next, this I'm not going to run because iteration 2, iteration 3, iteration 1, 2, 3, 4. So I mentioned iteration 1, no? So here, if you see in our previous cell where iteration 1 is there, 1 and 4. So here I updated only few columns. So, and other few columns I am updating here. Okay, that is this one here. So here what I'm doing, customer underscore value, I am updating here. So I have to run this cell also. Next, since I mentioned iteration 1, so this also I have to run product underscore volume column, and this not required, and this also not required. Okay, so now for iteration 1, what is the output here? Where is iteration 1 lost is there? This one. So this one, product underscore df, up to here we are running, and this data we are writing to Delta Lake. Okay, so here we are writing to Delta Lake. So that is this one. So in iteration 1, we are getting 3 million records. Okay, so now we'll come to iteration 2 for next 3 million records. If you come here, if you come up here, for iteration 2, we already run this 2 cells for iteration 1. So, okay, so next, one more time, I am running this one. So I mentioned iteration 2 now, so I am running here. So I am generating 3 million records again with all duplicates. After that, I will not run this. I will not run this. I will run this one. Iteration 2 I given now. So here I am upgrading few columns compared to iteration 1. Few changes I did. Like in iteration 1, I given 12%. So here and here 12% I given, that too with more more distinct values. Here I reduced. Okay, so that is the difference between iteration 1 and iteration 2. Okay, so now this cell will run, this we don't run, iteration 3. This cell will run for customer underscore value, not this one, and this will run product volume start, iteration 2, and this also product volume end, iteration 2. Now this is our final data frame. This one, what I'm doing is, I am doing here append. So here I mentioned no append. After running second iteration, if I run this one, it will get append to existing table. So that means initially we have 3 million rows. Whenever you do second iteration, when second iteration completes, when you try to run this count, it will become 6. That means already we have 3 million, and in second iteration, it generated 3 more millions. So total we have 6 millions now. Now we'll go to top and we'll check for iteration 3. So first 2 cells we have to run it, already run, and this we have to run it for third iteration. It will give you again 3 million records with all distinct values, duplicate values. This I'm not running. This I'm not running. This also I'm not running. Iteration 3. This I'm running. See here, this logic is same for all iterations, but only these percentages will change. Okay, so these percentages and the number of distinct values will change. This is iteration 3. This cell I will run, and this also I will run, and this also I will run, and this also I will run. So that means each and cell we are updating one column. Okay, so this will not run. So now final is this one. So this result we are doing append to existing delta table. Okay, so now why I'm doing separately here is count to show the difference. So when initially 3 million, when after doing second iteration, we are getting 6 million. Now after completing third iteration, we are getting 9 million. Now we'll go for fourth iteration. These two common, and this I'm not running for remaining 1 million. Instead of that, what I'm doing, iteration 4, see why I did separately is, so here we mentioned 3 million, no? So, but fourth iteration, I want only 1 million. So I given separate cell with 1 million records. So here also, it generates 1 million records, but duplicate records. Since I given iteration 4, so for iteration 1 and 4, I'm keeping same ratio, same percentage and values. I will update that one. This not required. Iteration 2 not required. This also not required. This I will run. So customer underscore value column will get update. And similarly, this also product underscore volume also. This I'm not updating. This I'm updating product underscore volume underscore and okay, now this is our final data frame. So this I'm one more time appending to existing table. So now if I go for iteration 4 and if I check count, already we have 9 million. Now it will append 1 more million. So that means total now we have 10 million records. Okay, so you can identify with this text iteration 1, 2, 3, 4. Okay, so why I'm doing these different iterations is when we did first cross join, we are getting all 10 million records as duplicate rows. So like this, I segregated. If you see my scenario 8 video, there also I used a cross join, but I'm not used this method. I approached different method. So this is totally different method. Okay, so that's all about this video. If you really like this video, please like and subscribe. And if you have any doubts, please comment on this video. Okay, thank you.